Hi, welcome back to our series on matrix. So far, we have learned some of the basic operations in matrix, which is addition, subtraction, and multiplication. Today, we will learn about another unique matrix operation, which is known as the transpose of a matrix. Now, consider this matrix, matrix A, which has a 3 by 3 order and hence has 3, 1, 2 and 3 rows and 1, 2 and 3 columns. Now we know how to represent each element of a matrix, which is by first row first column would be A11, first row second column would be A12, first row third column would be A13. But now look at matrix B. Here the references are a little reversed. You see 1, 2 and 3. So first row first column remains the same as A11, but second column first row instead of being A12 is called A21 in this matrix, which simply means this element has been moved out to this place and that element that's moved out to the other place. Similarly, if you were to put in a different color, see A31, if we move it to here, and A13, if you move it back here, you get this configuration, right? So A13 is here and A31 is here. So transpose is essentially means shifting the elements which is not in the diagonal. These are the diagonal elements. These are the diagonal elements. A11, A22, A33. Elements which have same row number, column number equal are called your diagonal elements, right? Now, non-diagonal elements, Aij becomes Aj in transpose matrix. Okay. So in this kind of a configuration, B is said to be transpose of A. The way we write transpose is A with an apostrophe over it, right? Now let's take a numerical example and understand how to do an A transpose. Suppose A is equal to, let's just take any 3 cross 3 or 4 cross 4 matrix. Let's take a matrix of 3, 3, 2, minus 1, 4, 5, 3, 7 and 8. A dash would be arrived at. So what did we say? The diagonal elements remain the same. So these will remain the same. So these will become 3, 4 and 8. Now what do we do with the non-diagonal elements? We reverse their position. So 3 is here in column 2, row 1, it will come to row 2, column 1. So 3 comes here and minus 1 which is here has to go here. Understood? Similarly, 2 which is column 3 row 1 will become column 1 row 3 and this will become row 1 column 3, right? Same we have to do with these two. Just reverse their positions and what you have is a transpose. In the next video, we'll learn how to use a transpose of a square matrix to arrive at a symmetric and a skew symmetric matrix. So transpose is nothing but keeping the diagonal elements same and flipping over the positions of the non-diagonal elements. So they just move to the corresponding other locations and then you get a transpose matrix. It's a very important concept. Now keep watching Maths and Tuition. Subscribe to Maths and Tuition to know when we post a new video. Thank you.